Welcome to this deep dive. We're jumping straight into the whirlwind that is artificial
It
intelligence.
really is everywhere, isn't it?
Absolutely. You've seen the headlines, heard all the buzz, and today we're gonna, really try and dissect what's actually going on.
Hmm.
Our sources for this are, well, pretty great actually. A discussion with AI experts Arvind Narayan and Melanie Mitchell, plus some sharp points from Kaijo Tolman's article, Unmasking the Hype Around AI.
Yeah, really solid perspectives to draw from. Narayan and Mitchell especially bring such different but complementary views.
Right. So our mission really is to cut through that hype and give you a clear, more grounded understanding of what AI can do now, where it kind of stumbles, and what
Yeah.
might really be next.
It's crucial. There's just so much excitement, which is great, but also, frankly, a lot of misunderstanding about these systems' actual capabilities.
Totally agree. Let's kick off with something Arvin mentioned, this elephant problem. It's quite a story.
Ah, yes. With ChatGPT.
Exactly. He asked it to make an image of a room, specifically without an elephant. And, well,
It put an elephant in the room.
it did. And the kicker is the text part insisted there wasn't an elephant, even though you could clearly see it in the picture it generated.
Right. And it's not just some weird glitch, is it? It points to something fundamental about the architecture.
That's what Arvin said. It's because the part that talks the chatbot and the part that makes the image are like totally separate systems. They can't see what the other one is doing.
Exactly. They operate in these functional silos. There's no integrated understanding, no common sense linking the language request to the visual output. It's a huge difference from how we operate.
It really highlights that lack of, well, common sense, doesn't it?
It does, and it's not just vision and language. Arvind also talked about trying to play rock, paper, scissors with chatbots.
Oh, yeah, that was fascinating. Even when you figure out you can always win because they have to type their move first.
They just can't adapt. They don't grasp that the text interface changes the whole dynamic of the game. They lack awareness of their own environment, their own UI even.
It's a real lack of context awareness. Brilliant inside their box, but easily tripped up by things a kid would get instantly.
Melanie Mitchell has a great way of putting this. She talks about current AI lacking a sort of frontal cortex.
Okay, the brain analogy, what does she mean by that, like executive function?
Pretty much. She's talking about metacognition, that ability to be aware of your own knowledge, knowing what you know, and maybe more importantly, knowing what you don't know.
Ah, okay. That self-awareness piece, knowing your own limits.
Exactly. It's crucial for avoiding errors, especially confident-sounding errors, and current AI just doesn't have that. Mitchell also points out they lack episodic memory.
So no memory of past conversations or experiences like we have.
Right, each interaction is often like starting fresh. And that combination memory of past events plus knowing your own understanding that's vital for genuine learning and avoiding repeated mistakes, AI isn't there yet.
So this inability to connect the dots, like the text in the image or the rules of a game and the interface, that's tied to this lack of common sense and metacognition.
Precisely. And it's interesting how Narayan and Mitchell approach this. Narayan often looks at the sort of outward behavior, the societal impact, the economics.
For real-world effects.
Yeah, whereas Mitchell dives more into the internal workings, thinking about how it compares to human cognition, like using psychology and neuroscience as analogies.
And we need both perspectives, don't we, to really get the full picture.
Absolutely. It's even more complex because, as they both acknowledge, even the developers, the people building these things at places like OpenAI, don't always fully understand why the AI behaves in certain ways.
That's kind of mind-blowing. We've built something that powerful, but its reasoning is partly a black box, even to its creators.
Yeah, the complexity is immense. And that leads directly into what Mitchell calls the crisis of evaluation. How do we even know how good these systems really are?
Because passing a test isn't the same as actually doing the job, right? Like the bar exam example.
Exactly. Passing the bar exam or a medical licensing exam on paper is one thing, but it doesn't mean the AI truly understands the law or medicine, or could handle the nuances of being a lawyer or doctor in the real world.
And Arvin's example of the lawyers getting sanctioned, that's pretty stark.
It really is. Submitting briefs with fake case citations generated by a chatbot because they treated it like a search engine or a database.
Instead of a language model that, makes stuff up sometimes.
Precisely. And Arvind made the point that while this was big news initially, these kinds of failures are becoming almost routine, just maybe less reported now.
Which just screams for better ways to test these things, doesn't it? Independent evaluation.
Definitely. Marian draws that parallel to the auto industry before independent safety testing, like the EPA or Consumer Reports. We need that kind of robust third-party assessment for AI.
Because the old ways don't cut it anymore. That one-dimensional hill climbing contest idea.
Yeah, focusing just on accuracy on specific data sets like ImageNet was fine maybe for older single-task AI. But for today's multi-talented systems, it's way too narrow. We need to evaluate understanding, reliability, safety, a much broader set of criteria.
So projects like the Science of AI evaluation are trying to figure that out.
Exactly. It's about fundamentally rethinking assessment beyond just hitting high scores on benchmarks.
Okay, so if evaluation is tricky and they lack common sense, what about all the talk of AI taking over jobs? Like Bill Gates predicting AI doctors and teachers soon.
Well, it's a big one. Date suggested within a decade, potentially. But as Mitchell points out, history is kind of full of AI experts being overly optimistic about timelines.
Right. And Narayan has a really interesting counter to that, doesn't he? He argues these predictions often come from a maybe shallow understanding of what the jobs actually involve day to day,
Yeah, he used Jeff Hinton's 2016 prediction about radiologists becoming obsolete within 5 years.
which clearly didn't happen.
Not at all. It seems the professionals in those fields, the doctors, the lawyers, the teachers, often have a much better grip on AI's limitations within their own work than some AI researchers do.
It sounds a bit like the hype around expert systems back in the 80s.
Very similar parallels. The big hurdle then and now is capturing that tacit knowledge, all the intuition, the experience, the unwritten stuff that's crucial for complex jobs. It's really hard to just code that.
This seems to lead into another point Arvin made about this growing gap, this disconnect between the AI labs and companies and the general public.
Yes, that communication gap is becoming a real issue. It's not just about technical understanding. It can breed mistrust, even backlash, especially if companies aren't clear about what's real progress, what's just hype, and why they're pushing AI so hard.
Like the example of Microsoft putting AI in Office and users just wanting to turn it off.
Exactly. It suggests a mismatch, doesn't it, between the tech company's vision and what users actually find helpful or necessary. Narayan really emphasizes that AI development needs more than just computer scientists. It needs sociologists, ethicists, domain experts.
A broader perspective. Okay, let's pivot slightly. This fundamental question. Are these things actually thinking or reasoning, or is it just like incredibly advanced mimicry?
That's the million-dollar question, isn't it? Melanie Mitchell makes a great point that words like thinking are actually, well, they're pre-scientific. We don't have a precise neurological definition, even for humans.
That's true. So applying it to AI is maybe jumping the gun.
It can be, and she notes how the language we use, calling them reasoning models, talking about chains of thought, really shapes how we perceive them. It nudges us towards anthropomorphism.
And then there's the stochastic parrots idea.
Right. The argument that these large language models are basically just predicting the next most statistically likely word based on trillions of examples from their training data without any real understanding of meaning, like a parrot repeating phrases.
So, brilliant pattern matching, but no comprehension.
That's the core of that argument, and it's a debate with huge philosophical and even emotional weight, beyond just the technical details.
It does feel hard to avoid that humanizing language, though, even when you know better. The way they talk sometimes.
Oh, absolutely. When a chatbot says, "I think," or "I want," it triggers that response in us. It's related to the Eliza effect.
Ah, named after that early chatbot.
Yeah. It describes our tendency to project understanding, intelligence, even feelings onto systems just because they can use language fluently, even very simple systems sometimes. Our own psychology is playing a big part here.
So, given that we're kind of wired to do that, Arvin suggested maybe you should educate kids early about how AI actually works to try and counter that projection.
It's a really interesting thought. Could we sort of inoculate the next generation against the Eliza effect by giving them a more realistic understanding from the start?
Can that tendency even be overcome, though? It feels pretty deep-seated.
That's the big question. Maybe not entirely overcome, but certainly moderated with awareness. Talking about it early seems crucial, especially since they'll grow up with this tech being even more integrated.
Definitely. Now, circling back to the elephant problem, we had a listener ask why the image generator can't just look at its own picture.
Right. And as we said, it boils down to them being separate systems, Fundamentally, the language model sends the instruction, the image model makes the picture, but there's no feedback loop, no common seeing. Integrating these different modalities, vision, language, maybe others, is still a major research challenge.
Although you mentioned there's progress there.
Yes, very recently, actually. Companies like Google and OpenAI have announced models where language and image generation are more tightly integrated. So that specific elephant problem might get solved soon. The field moves incredibly fast.
Okay, good to know. Another big area of concern people raise is the environmental cost. Training these huge models, and it takes a lot of energy, right?
It does. There's the global carbon footprint of the data centers, which is significant. But some experts, like Hannah Ritchie, argue the more immediate issue might be the local impacts.
Local, like where the data centers are built.
Exactly. Huge demands on local power grids, massive water consumption for cooling, impacts from mining materials for the hardware. These can be really disruptive for specific communities.
And the sheer scale of data and computation. It seems orders of magnitude more than how humans learn.
Vastly more in terms of raw data processed. It does raise questions about sustainability. That extreme example, maybe needing to restart old nuclear plants just to power AI, really drives home the potential energy demands if things keep scaling up.
Beyond the environment, there are other worries, like over-reliance leading to de-skilling, and of course, bad actors using AI.
Both are very real concerns. The de-skilling issue is complex. The goal should be augmentation, using AI to help humans do things better, not just replace them wholesale. And yes, misuse is a danger.
But there's a counterpoint.
Well, historically, automation often helps defenders, too. Think cybersecurity AI is already being used to detect threats faster. It's an ongoing arms race in a way, but it's not purely one-sided towards the attackers.
That's somewhat reassuring. And we're also seeing efforts to make AI more efficient, right? Less resource hungry.
Absolutely. Models like DeepSeek are examples of trying to get similar performance with much smaller, more efficient architectures. And sometimes constraints, like maybe export restrictions on the most powerful chips, actually force innovation and efficiency.
That's interesting, the idea that having fewer resources can sometimes drive better solutions.
It's a common pattern in tech. Constraints can breed creativity. You don't always get the best outcome just by throwing infinite resources at a problem.
You mentioned earlier this paradox. As AI gets better, we trust it more, making us more vulnerable when it fails.
Exactly. That's a really tricky aspect. The more capable and seamless AI becomes, the more we might lower our guard. The self-driving car example, working perfectly 99.9% of the time, then suddenly breaking hard for a billboard, it misinterprets that failure becomes much more jarring, potentially dangerous, because we've come to rely on it.
Yeah, that makes sense. Now, there seemed to be a slight difference in perspective between Narayanan and Mitchell on embodiment. Does AI need a physical body to be truly intelligent?
It's a nuanced difference. Both agree that active learning, learning through interaction, through doing, is crucial, much more so than just passively absorbing data.
Okay, so interaction is key for both.
Yes. But Mitchell leans more towards the idea that embodiment, having some kind of physical interaction with the world, might be a more efficient, maybe even necessary path to human-like intelligence. She draws on psychology research about embodied cognition.
And all right,
He seems more open to the possibility that a sufficiently rich digital environment, allowing for that active interaction, might be enough. So maybe not a physical robot body, but deep interaction within a complex simulation, perhaps. It's still an open debate.
interesting. Arvind also stressed that the bottleneck for AI's impact isn't just building bigger models anymore, it's the implementation, right? Getting it used effectively.
Precisely. He talked about how initially there was this idea that these general models were so powerful they wouldn't need much specific product development, just unleash the API.
And that's changing.
It seems to be shifting. There's a growing realization that you need careful design, user focus, and real thought about integration into workflows to make AI genuinely useful in specific areas. It's not just about the raw capability of the model itself.
Makes sense. We also had a listener ask about the role of math in all this. How important is it?
Oh, absolutely fundamental. Machine learning is built on math, linear algebra, calculus, probability statistics. That's the bedrock.
You can't really do AI without it.
Not seriously, no. And what's fascinating now is AI is starting to be used in mathematical research, helping prove theorems, suggesting new mathematical ideas. It's becoming a tool for mathematicians, too.
Wow. Okay, one last big area, privacy. With tools like Copilot in our documents, or Claude analyzing our conversations,
Yeah.
How does this change things?
That's a huge question. Narayan brought up historical parallels, like when photography became widespread.
Right? People worried about being photographed in public.
Exactly. And society adapted. New laws emerged, social norms about where and when it was okay to take pictures developed. He mentioned the Google Glass backlash too, society pushing back against constant, potentially covert recording.
So the idea is we'll adapt again.
There's a degree of optimism, yes,
Yeah.
that it will likely involve a mix of new laws, changing social expectations, and maybe technical solutions like privacy-preserving AI techniques. But it's definitely something we need to actively navigate.
Okay, finally, let's touch on Alison Gopnik's framing of AI. Not as an artificial person, but as a social and cultural technology.
Yeah, that's a really powerful lens. Thinking of AI less like an alien intelligence and more like the printing press or writing tools that fundamentally changed how humans store, share, and process information and how society organizes itself.
And the metaphors we use really matter.
Hugely, especially in legal and policy debates. Is an AI more like a tool, like Photoshop or an author when it comes to copyright? The metaphor shapes the outcome, and Naranina really drives home that artificial general intelligence, if it ever happens. It won't just be about the software. It'll be this emergent thing arising from the software, plus all the social, legal, technical, and institutional changes we build around it. That's a decades-long process, not just a software update.
Right.
Oh.
Okay, so wrapping up this deep dive,
Hmm.
it feels like the key takeaways are current AI is amazing at pattern matching, but it's missing genuine understanding, common sense, that metacognitive awareness, and human-like memory.
Definitely. And evaluating it properly is a massive challenge, needing new independent approaches.
And those predictions about imminent job takeovers probably need a grain of salt, often missing the complexity of real-world work.
Mm-hmm. Plus, we really need to think hard about the broader impacts, environmental costs, misuse potential, privacy shifts, and making sure the public is part of the conversation, not just the tech labs.
Absolutely. So maybe a final thought for everyone listening to chew on.
Yeah.
Given all these limitations we've talked about, the lack of true understanding, the potential for unexpected errors, the evaluation challenges, how might this actually impact your interactions with AI? Both right now and looking ahead, what does it mean for how we learn, how we work, how we trust technology that doesn't get things the way we do?
That's a great question. It really pushes us to think critically about how we integrate these powerful but flawed tools into our lives. It's definitely something worth keeping in mind.